Okay, so here we want to look at the broom as our system, and it has mass m. And before we begin, we should probably talk about a little addition to this problem, and that's that it should say that it's moving at constant velocity. So let's assume that it's moving at a constant velocity, and we'll say that that constant velocity is actually to the right. So we'll say constant velocity, little arrow showing us the direction. Okay, so let's set up our system. We have the broom, and if I represent its center of mass with a little dot, and then I draw the weight force of the object, which would be mg. There's some force of support from the surface, so that would be the normal force. And part of this tension is actually going to push the object down and to the right, so tension. We will say that the x component of that tension, or Tx, is going to push it forward, and then the y part of that tension, Ty, is going to push it down. Now, if I think about the angle that theta makes with the horizontal here, it's the same as this angle theta there, so we can just go ahead and safely put theta here on our free body diagram. And the other force that I have is friction. Now, I don't know what to do with mu right away, but I do know that there is some friction. Now, all of my answers have t sine theta, t cosine theta, mg, all of this good stuff. And if I would like to figure out what it is that the normal force is equal to, I'm sorry, the frictional force, then I'm going to add up all of the x forces and all the y forces. So I add up Tx minus friction, and that's actually going to equal the mass of the system times the acceleration of the system. Now, since there's a constant velocity, I know the acceleration of the system is 0, so that means that these two things are actually going to add up to 0, which allows me to say that Tx is equal to friction, because I can add friction to both sides of the equation. Now, Tx isn't one of my choices, but I do know that this is the vector component of t, so I can say Tx is really the magnitude of t times cosine of theta, since theta is touching this component. And when I write this for friction, I see that it is just t cosine theta, and that is d.